everybody, welcome to this week's topic of biodiversity thresholds. This week we're going to spend some time interrogating this important concept and asking the question, why are biodiversity thresholds an important concept in conservation? So the starting point really needs to be, what is an ecological threshold? Well, to answer this question, we're going to use an example of a physical system that we're all very familiar with that actually uses thresholds. So we all know what happens to ice if we leave it outside in the sun. It melts and it changes into a new state, which we refer to as a liquid. If we leave it outside for a little longer and it's a nice warm day, that liquid eventually evaporates and we end up with water in its gaseous form. So what we're really talking about here are the three stable states of water. In its solid form, it's known as ice. It then moves on to a liquid form in the form of what we refer to as water. And finally, we have its gaseous phase. Now, what controls the movement between these alternate stable states? That's really regulated by temperature. So we all understand that under cold temperatures, ice forms when water freezes. As it gets warmer, it moves into a liquid phase, and only when it boils does it reach its gaseous phase. What's important here, though, are there are critical points where water moves from one phase to the other. So if we're looking at the lower end of this continuum, what we will see is that water can be at a temperature anywhere below 0 degrees, and it will be in the same stable state. It will remain frozen. However, above 0 degrees, it's a tipping point, a critical point where it changes from that solid state into the liquid state. At the high end of temperatures, there's another critical point. That's around about 100 degrees. When water is above that temperature, it's only present in its gaseous phase, which means it evaporates. So these critical points are what we refer to as physical thresholds. So maybe that gives you a hint about where we're going as far as ecological thresholds go. So ecosystems occur along a continuum, right the way from fully functioning healthy systems through to intermediate systems, and then right down the other end we have degraded ecosystems. And these really can alternate between these different stable states. What underpins those stable states is ecosystem health. And ecosystem health is often quantified as the proportion of intact habitat. So really what we're saying here is that fully functioning healthy ecosystems tend to have high proportions of intact habitat. And as habitat becomes degraded, so these ecosystems move slowly from fully functioning through to intermediate ecosystems right the way through to degraded ecosystems. However, just like our example with water, there are critical points, critical thresholds that ecosystems move towards before they actually change between these alternate stable states. These are what we refer to as ecological thresholds. So now that you understand what ecological thresholds are, here are some pointers to guide you through this week's work. These are really key concepts that you should interrogate while you're doing your readings in preparation for this week's lecture. I've listed 4 questions that you should be able to answer by the time that you're finished with this work. So please spend some time working through these different questions. If there's anything that you're uncertain about, you're very welcome to get hold of me.